Hello everyone. This session I will cover the numerical example of the hierarchical clustering. In the previous session, we discussed the basic concept of hierarchical clustering, right, and steps that is involved in the hierarchical clustering, and also the different techniques, merging techniques, those we use to merge those we can use to merge the clusters in the iteration of the clustering process. So here we will discuss one numerical example for the single linkage clustering first, right? So in the single linkage clustering, you know that minimum distance clustering is also called as the single linkage hierarchical clustering or nearest neighbor clustering, right? And the distance between the two clusters is defined by the minimum distance between the objects of two clusters as shown in below. So here, as shown in this figure, the minimum distance between the two objects of these members of the cluster we consider as the distance between the two clusters. So here a star is the one cluster and triangle is the another cluster, right? So this minimum distance is nothing but the distance between this nearest point here between these two clusters. Right. So how you can solve here example using this method that we can discuss here. Assume your data set is given. My data set can be two-dimensional, three-dimensional data. Here actually this data set is a two-dimensional data. So what is my data set here? Just for that I am going here. So my data set is a two-dimensional data represented by this x1 and x2 attributes, right? And in my data set there are total 6 objects. So A, B, C, D, E, F, these are the objects in the data set, and these are the values associated with the x1 and x1 attribute of these objects, right? So this method starts here with the distance matrix. So here first step is to calculate the distance matrix. So here we have calculated the distance matrix for my data set. So there are total F objects. So my distance matrix is what here 6 by 6 matrix, right? So this distance matrix was calculated based on the object features as explained in the previous session. That is by using Euclidean distance. Here you can calculate the distance between these objects. So either you can consider this pink portion or green portion. So assume this is my this is the distance matrix representing the distance between the each and every object in my data set, right? Now how this method starts here we have 6 objects and we put each object into the one cluster. So in the first step, right, you know that every object represents the one single cluster. So my in the first step or initial stage, my every cluster is of the single object only. So instead of calling the object, we are calling them as a cluster. Again, I am repeating here. Instead of calling the object, my every object will be now the clusters here, right? So thus in the beginning we have 6 clusters with us, right? So our group is what? Our goal is what? To group those 6 clusters such that at the end of the iteration we will have only single cluster consist of the whole 6 original objects. That is the idea behind the agglomerative cluster. Actually, agglomerative clustering is the bottom-up approach, right? And first we start with all the clusters, objects as one single cluster, right? So in each step of the iteration, right, we find the closest pair cluster, and in this case, the closest cluster is between the cluster F and D with the shortest distance. So now, if you observe this matrix, student, in this matrix, distance matrix, find out which distance is the closest distance. So if you observe this distance between the object F and D, which is highlighted by the red color, is the closest distance, which is 0.5, right? This is the smallest distance. So in the first step, we identify here which two objects are closest and that we merge together, right? So here we group the cluster D and F together in the first step. So after merging this F and D or D and F objects together, cluster together, we will get here the new matrix, distance matrix. Now we have A, B, C, then D, F, we have merged together an E object, right, or the cluster. So here now, instead of 6 cluster, in the second iteration, we will have the 5 cluster. My first cluster is again A, second is B, C, and fourth cluster is now D and F, right? And my fifth cluster is E. Now you need to calculate. Now we are using here single linkage method, right? So in the first iteration, actually we do not apply the concept of single linkage because every cluster is having only single object, right? Now in the second iteration, we will calculate here the distance between this DF cluster and each and every other object in the here each and every other cluster in the data set, right? So now here my D and F, DF is the one cluster and distance between the DF and A cluster will be represented by the single linkage method. Now what is the single linkage method here? So we are calculating the distance between the DF and A cluster. So minimum distance of what? The distance between DA and D, distance between the FA object, right? So in this cluster, we have two objects, D and F. So calculate the distance between D and A. Then another, calculate the distance between the F and A and check for the minimum distance. So which is the minimum distance, either DA or FA? So here my distance between the DA is the 3.61 and distance between the FA is the 3.20. So these distances you will get from my original distance matrix. This is my initial distance matrix. So distance between FA is 3.20 and distance between the DA is the 3.61 here, this one, right? So that we have taken this from this matrix and you check for the minimum distance. So which is the minimum distance? That is 3.20. Right, so this 3.20 will represent the distance between the cluster DF and cluster A here, right? I hope students you are clear with this. Now we have obtained this value. Here we have put the question mark and we have calculated this value. So this value we are getting 3.20, right? Now calculate the distance between DF and my B cluster, right? My DF cluster and B cluster, this one. Now, how you will calculate this? Again, repeat the same process. That the distance between DF and B cluster is equal to minimum of the distance between the DB and the distance between the FB. Then calculate here the distance between DB. So what distance between DB is 2.92 and distance between the F and B object cluster is 2.50. So minimum distance is 2.50. So this 2.50 will represent the distance between my cluster DF and cluster B. Right, so this will be the distance between DF and B. Similarly, you can calculate the distance between DF and C, right? And also you can calculate the distance between DF and E, right? By using this single linkage. Why we are taking minimum distance? Because it is a single linkage method for calculating the distance between the two clusters. So here we have obtained the distance between the DF and C cluster 2.24 and DF and E cluster, that is 1. So after calculating these distances, you will get this resultant matrix, updated distance matrix. So here you can put these values. Those are highlighted by the blue color, dark blue color here, right? So now once you have obtained this new matrix by forming this new cluster, that is DF, right? Then you can find out now which two cluster you can merge together in the third iteration. So you check for the minimum distance. So here the minimum distance, smallest distance is what? Between the object A and B. In this resultant matrix, the shortest distance is A and B, that is 0.71, right? Now you can merge A and B object together, right? So in this iteration, I will merge A and B together. Now, after merging this A and B together, you will get this resultant matrix, right? Now, instead of 5 cluster, in this iteration, you have only 4 clusters. So first cluster is of 2 object AB, second cluster of C object, third cluster of DF object, and fourth cluster of E object here, right? Now, you calculate here the distance between, right, the object C and AB, object DF and AB, and object E and AB. right? So apply same process of single linkage method to calculate these distances. So now I want to calculate the distance between C and AB, right? The distance between here C and AB, right? So it is again the minimum distance between what? The distance between the object CA and distance between the object CB. So the CA distance is 5.66 and the CB distance is 4.95. The minimum distance is 4.95. So the distance between the cluster C and cluster AB is 4.95 here. Right now, next you calculate the distance between the cluster DF and cluster AB. Right, so you can apply again single linkage method here. So the distance between these two clusters DF and AB is equal to the minimum distance of what? All these the pair distances DA, DB, FA, FB. So from original matrix, you can get this value. So out of this 4 value, 2.5 is the minimum value. So this 2.5 is the distance between the cluster DF and AB here, that you can put here, right? Similarly, you can calculate the distance between the E and AB, right? The distance between the cluster E and AB. So by applying same process, we are getting here this distance, right? The minimum of distance EA and EB. So it's a 3.54 here. So the distance is 3.54, which is minimum distance in this two pair, right? So here we have obtained all the distances. We have calculated all the distances between the clusters. So my resultant matrix with the single linkage method will be this. Now these are the 3 value we have calculated, right? So this is the new updated matrix, a distance matrix for these 4 different cluster A, B, C, D, F, and E. Now in this resultant matrix, again updated matrix, check for the minimum distance. So my minimum distance is 1 here. So which 2 pair of the cluster we can merge here in this iterations where my distance is minimum. So here my distance is minimum, which is highlighted by the red color here. So we can merge now E and DF cluster, right? So we can merge here DF and E cluster. So again, by merging this, we will get here the new distance matrix here. So now in this new distance matrix, we have only 3 clusters instead of 4. So my first cluster is AB. My first cluster is AB. Second cluster is C. My first cluster is AB. Second is C. So new matrix have only 3 clusters here. AB, first cluster is my AB, second cluster is C with the single object, and third cluster is now with the 3 objects D, F, and E. Now you apply the same procedure to calculate the distance between these 3 clusters, right? So calculate the distance between AB and C, then your C and DF and DFE, right? And C. So these are the 2 values we have obtained in this iteration, 2.50 and 1.41, highlighted by the dark blue color, right? Now again in this resultant matrix, you calculate, you find out which is the minimum distance. So here my minimum distance is 1.41, highlighted by the red color, right? So now you can merge here which 2 cluster together in this iteration, D, F, E, and C together, because which is having the minimum distance are among all these distance values, right? So we can merge here DFE with the C. Right? So already we have calculated this. This is the solution for calculating the distance between the FE and AB. So here we have obtained 2.50 minimum distance between all these pair of the distances. Then second value 1.41 we have calculated here to calculate the distance between D, FE, and C. Right? Then after that we are now merging this DFE with this C. So after merging this DF E with this C, we are getting this new distance matrix, updated distance matrix. So here my instead of now three cluster, we have only two cluster to in my result. So first cluster is having AB object, and second cluster with the 4 object, that is D, F, E, and C. Right? So here the distance between, now you need to calculate. Now we have obtained this new cluster D, F, E, and C. So calculate the distance between this cluster and AB here. So if you apply the same procedure of single linkage method here, right? So take the minimum distance of all this pair of the distances, right? So you will get here 2.5, right? So this minimum distance is 2.5 here, right? And that is nothing but the distance between my cluster D, F, E, C and AB cluster, right? So this 2.5 is the single distance available now here in the matrix. So you can merge all these distances in the last iteration. You can merge this D, F, E, C and AB together, right? So you will get the single cluster, right? So if we summarize here, now, if we merge the remaining two clusters, we will get only the single cluster contain the whole 6 objects, right? And thus our computation is finished here for this algorithm. We summarize the result of computation here. So here in the beginning, we had the 6 cluster A, B, C, D, E, F. We merge cluster D and F into the cluster DF and for at distance 0.50. Then in the third iteration, we merge cluster A with the B at distance 0.71. Then we merge cluster E and DF into the DFE at distance 1. Then next iteration, we merge the DFE with the C at distance 1.41. Then we merge the cluster DFEC with the AB at distance 2.50. And in the last cluster, the last cluster contain all the objects. Let's conclude this computation. So after this, right, this step-by-step process, you can summarize in the dendrogram, right? So we can now draw the final result of the dendrogram, right? The dendrogram is drawn based on the distances to merge the cluster above here. So you can find here, first we merge DF, then DF we merge with the E, then also we merge here in the second iteration. Actually at this distance 0.71 we merge A, B together. At distance 1 we merge here the DEF, right? At distance 0.5 we merge here DF. At distance 0.71 we merge AB. At distance 1 we merge DF and E. At distance here near about 1.5 we merge this DFE with the C. And at distance 2.5 we merge the both the resultant cluster and with the single cluster. So this is the dendrogram for my solution. Also, this hierarchy of these clusters that you have obtained in the different iterations, you can represent in the scatter plot, right? So we can also plot the cluster hierarchy into the XY space here. So this is my XY space for this example, right? So here is the x-axis and y-axis, my data points x1 and x2, right? And in the first iteration, we merge D and F together here. Then we merge the A and B at this point, distance point 0.71. Then we merge here DF with the E. Then we merge this DFE with the C. And at last we merge this portion and this portion together, right? So this is the clustering hierarchy represented into the XY place. I hope student you are clear with this concept of the agglomerative clustering technique, which is a bottom-up approach, right? With example. Thank you.